In this example, we are going to assume that G and H are mutually exclusive events. Mutually exclusive events means that those two events cannot happen at the same time. For example, let G be the event that your birthday is in May, and let H be the event that your birthday is in June. Now, you cannot have event G and event H happen at the same time. No one can have a birthday in May and in June together at the same time. So that's an example of where you would have mutually exclusive events. Now, mutually exclusive events, because they can't happen together at the same time, the probability of those two events happening at the same time is going to be 0. So when you look at part A of this problem, it says find the probability of G and H. Because we know that G and H cannot happen together, that probability has to be 0. And again, that is because they're mutually exclusive events. Now, in part B, we need to find the probability of H given G. Because we're not given the information as data in a table, we're going to use our formulas. So we're going to use this formula right here. These have our conditional statements in it. And in this formula here, I have it labeled as C's and D's. We're just going to exchange it for G's and H's. So I'm going to replace my H's in place of C, and my D's are going to be my G's. Okay, so now I have written the probability of H and G is equal to the probability of G times the probability of H given G. We know that the probability of H and G is 0. That we knew because the two events are mutually exclusive. The probability of G was given to us right here in the formula, or in the problem. That was 0.47. And then the probability of H given C is what we're looking for. Now, think of this as an X. It's an unknown. That's what we're trying to solve for. So in algebra, if I said you have an equation 0 is equal to 0.47x, this is our unknown. To solve it, we would have to divide both sides by 0.47. So that's what I'm going to do. I'm going to take 0.47 and divide it on both sides. So now I have 0.47 over 0.47. Those disappear, or you can rewrite it as 1 if you want, but you don't need to write the 1 in there. So what you're left is with the probability of H given G is equal to 0 divided by 0.47. And when we do that, we know that that answer is 0. So the probability of H given G is additionally 0. Finding the probability of H or G, we need to use our OR formula. So again, remember, I'm replacing C's with H's and D's with G's. So this is G, this is H, and then this is the probability of H and G. With the OR statement, we have, this is what we're trying to find, the probability of H or G. This is what we're trying to find right here. So I'm going to take the probability of G, which is 0.47. I'm going to add it to the probability of H, which is given to us here, which is 0.27. And then I'm going to subtract the probability of H and G, which we know from part A is 0. So on the calculator, I'm going to take 0.47. Sorry, that's a little bit messy because I'm using my mouse here. That's 0.47 plus 0.27, and then subtract 0. And when I add those together, I'm going to get, let's see, 0.47 0.74. Okay, so down here for part C, my answer is going to be 0.74. Now, it's asking about whether or not these G and H are independent or dependent events. Now, we know if something is independent if the probability of G is equal to the probability of G given H, or the other way around. I can switch the letters around. I can say the probability of H is equal to the probability of H given that G has happened. If H and G are independent, then these values are going to be equivalent. This is going to be equivalent, or this is going to be equivalent. And the information that we have up here, I know that the value of H given G, if I take the probability of H given G, we found that to be 0. But if you look at the probability of H, that is not 0. In order for this to be considered independent events, those two have to be equivalent. Because whatever happens with G, it should not affect the probability of H, which means these two should be the same. Because these two are not the same, the probability of H given G and the probability of H, this is 0 and this is 0.27, we would say they're not independent events, or we could say they're dependent events. And we would say because these values are not the same.